There are 118 elements on the periodic table, but sometimes it seems like just a handful get all the attention. We're always talking about carbon and oxygen and hydrogen and nitrogen, maybe with a little iron and calcium thrown in if we're feeling extra generous. And sure, we're all made mostly out of those elements, and they're some of the most common elements in the universe, so it makes some sense that they get top billing. But there's a whole periodic table out there, and we humans are great at finding ways to use just about anything that sticks around for long enough. So here are 8 of the less famous elements that you might not hear about all the time, but still play surprisingly important roles in the technology all around us. Most people probably haven't even heard of praseodymium, but it's right there at atomic number 59, with the symbol PR. Praseodymium is a lanthanide, which means you'll usually find it sitting in the first row below the rest of the periodic table. This makes the table a little more compact, but there's also a good reason that chemists put the lanthanides in their own little section. They tend to share a bunch of common properties, since the electrons around the lanthanides can act pretty similarly from one element to the next. Lanthanides generally aren't great at conducting electricity, and they typically make strong bonds with other elements. Which brings us back to praseodymium. It makes strong, heat-resistant bonds with other metals, so it's perfect for things like aircraft engines, which have to withstand huge temperature swings without cracking or breaking. Those heat-resistant bonds are also one reason that glass made with praseodymium is used in a lot of welders' and glassblowers' masks and goggles. They need to be able to see through that glass without feeling the heat from what they're working on. Lanthanides can also make strong magnets, and praseodymium is no exception. But if you're looking for a powerful magnet, you'll probably want to check out one of praseodymium's neighbors. Neodymium sits just to the right of praseodymium. Its atomic number is 60. And like its neighbor, neodymium is also used to make heat-resistant glass, including the glass in tanning booths. It lets ultraviolet light through so that you can get tanned, but it blocks infrared light so you don't feel too warm. But neodymium's main use is in powerful magnets. A strong magnet needs 2 things. First, it needs atoms with lots of unpaired electrons, which make each atom into a tiny individual magnet, and second, it needs all of those atoms to line up with each other to make one big magnet. Neodymium isn't the lanthanide with the most unpaired electrons, but its atoms are among the best at all staying aligned. When neodymium is mixed with elements like iron, it can make some of the strongest magnets on Earth. They're pretty much everywhere, from inside spinning hard drives where the magnets are used to read your data, to MRIs where they can scan your body. The connection between electricity and magnetism allows us to move a coil of wire within a magnetic field to create electricity. That's why you'll find neodymium magnets in microphones. The sound waves from your voice move a coil of wire next to a magnet, which produces an electric current. It's also how most power plants turn something like moving water into electricity for your home. So really, if there's electricity running through something, neodymium's probably involved somehow. Light bulbs usually shine in a whole range of colors, but lasers are different. Lasers use crystals whose atoms and electrons are arranged so that if you give them a bunch of energy, they shine and amplify light only of a very specific color. And if you're looking for a laser crystal, you can't do much better than YAGs. Yttrium aluminum garnet. Yttrium is one of 4 elements named after the small village of Ytterby, Sweden, where 7 elements have all been discovered. On their own, YAGs are pretty strong and heat resistant, but they don't really give off any light. But if you replace about 1% of the yttrium with another similar element, like erbium or neodymium, that's when things change dramatically. Doped YAGs, as they're known, are some of the best laser crystals out there, and they can be just about any color depending on the element that replaced yttrium. YAG lasers are the ones doctors use for laser eye surgeries, and they were also probably used to cut the components on your computer's hard drive. So even if you've never heard of them until just now, YAG lasers are the reason you can watch this video in the first place. So far, we've just talked about elements that exist naturally on Earth. But americium is different. No matter how hard you try, you won't find natural americium anywhere on the planet. But there's probably some americium in your house right now. Like all the elements larger than uranium, americium is radioactive. It decays into other elements over time by shooting out different kinds of particles. Every second, for about 30 years, a millionth of a gram of americium-241 sends out about 100,000 alpha particles, which are made up of 2 protons and 2 neutrons. So if you put a detector nearby, you'd be able to catch a lot of those particles as they flew out of the americium atoms, unless something else got in the way. Which is how the most common type of smoke detector knows when to go off. These smoke detectors have about a microgram of americium near a detector. And as long as nothing gets in between them, the detector keeps on sensing particles coming out of the americium. But once there's too much smoke in the air, or anything else really, it blocks those particles from getting to the detector, which sets off an alarm. Some radioactivity can be dangerous, but the kind in a smoke detector can also save your life. Californium is another radioactive element that you won't find naturally anywhere on Earth. It decays by sending out lots of neutrons, which can kickstart a chain of reactions used in nuclear power plants. But that's not the only place you'll find people using californium. It's also used before before companies extract oil. Before oil companies drill somewhere, they need to know how much water there is in the rocks and in the oil. The more water in the oil, the harder it is to get each barrel of just the oil out of the ground. So the company's engineers use nuclear moisture gauges, which measure the water in the rocks based on the way the water reflects neutrons. There's a small sample of californium in the gauge that sends neutrons into the surrounding rocks. The gauge analyzes what gets bounced back and uses that information to calculate how much water is in the rock. By making similar measurements, engineers can also test how dense the rocks are, giving them an idea of how hard it'll be to get to the oil in the first place. And they could do all of this with an element no human had ever seen before 1950. Speaking of dense rocks, let's talk about the densest element on the entire periodic table. Osmium. Osmium's electrons all orbit especially close to its nucleus, so its atoms can pack closer together than those of any other heavy element. It's so dense that engineers actually don't really use it to build very much. It's just too heavy to be worth it, especially when other metals are both stronger and lighter. But one place osmium used to be very common was record player needles. Needles with osmium didn't wear down from dragging along records nearly as quickly as other needles did. The strong, close bonds that osmium makes with other metals just don't bend and break under that sort of rubbing stress. For the same reason, you'll probably find osmium in the tip of a good fountain pen. Just like record player needles, fountain pens need to be able to rub against different surfaces for hundreds of hours without wearing out or changing shape. And super dense, super hard osmium is perfect for that job. So if you're playing vinyl records or using a fancy pen, there's probably some osmium involved. People have used antimony for thousands of years, all the way back to ancient Egypt and Rome, where they put it in cosmetic products. That's actually where the strange-looking SB comes from in its symbol on the periodic table. The Latin word that the Romans used for antimony was stibium. But today, we mostly use antimony for making flame-retardant plastics. Fire is mostly a lot of carbon atoms bonding with oxygen in the air and producing heat, so a good flame retardant stops those bonds from happening. And that's exactly why antimony trioxide, an antimony atom bonded to 3 oxygens, is added to a lot of plastics. When it's combined with other compounds that contain elements like bromine or chlorine, it'll bond with oxygen in a way that produces less heat, stopping the fire. So antimony trioxide does its job and stops fires, but there is one big drawback to using it on plastic. The hot plastic tends to release a lot of smoke that might be worse for you than the burning plastic itself would have been. Let's finish off with another element from Iterby. Gadolinium. It's just 4 elements over from our old friend neodymium, and it can make even stronger magnets than neodymium does because gadolinium has more of those unpaired electrons. But its atoms get too disorganized and stop pointing in the same direction above about room temperature. Above room temperature, gadolinium atoms just align with any magnetic field they happen to be in. That makes them pretty useless for things like fridge magnets and microphones, but they're great for MRIs. MRIs map out what's going on in your body by measuring how different regions respond to the magnetic field generated by a big moving magnet. And no matter how much you might feel like you're pulled toward the fridge at night, your body just isn't all that magnetic. So, a lot of MRI patients are given a small injection of a solution containing gadolinium. As the big magnet passes over, the gadolinium moves a lot in response to the magnet, which makes a much bigger signal for the MRI to measure, which leads to a much better map of whatever's going on in there. So even the more unusual elements in the periodic table have their place in the technology around us. Whether they're keeping airplanes working, detecting smoke, or being used in medical scans, these less popular elements help power the world. Thanks for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support the show, just go to patreon.com/SciShow, and don't forget to go to youtube.com/SciShow and subscribe. Skinny jeans can get a little uncomfortable, yes, and maybe you have a friend who spends more time waxing his mustache and trimming his beard than he actually does bathing himself, but your fashion choices probably won't kill, burn, or